Hello guys. So now we are bouncing on the two-dimensional type of the Venn diagram. So here we have a question. So later we are going to do the proof of how they result to this kind of equation to solve the problem. So in a class of 30 students, every student have at least a ruler. If 25 students have white rulers and 20 students have yellow rulers, how many students have rulers of both colors? How many students have rulers of both color? Alright, so in this question we are talking about, you have to read it up so you should know what they are talking about. So we are talking about what? The white ruler and the yellow ruler. Sure you get. So the white was coming first. So we're talking about the white ruler and the yellow ruler. So but first and foremost you have to analyze out the data set. You understand? I will use two methods to solve it. So I'll teach you two methods actually. So the first thing is that bring out the universal set. You understand? So the universal set here is in a class of 30 students. So the universal set here is 30. Okay. So you can also represent it as, because we're talking about white and yellow color, so you can also represent it as n into white union this. So it's also implied this. You can represent it as this as well in case you are told to find this, so you can know what they're asking to find. But normally, so you list out the universal set first. That's the first thing. So every student have at least a ruler. That's not the issue. So if 25 students have white ruler, so number of those who have white ruler, they are how many? They said they are 25. What else again? 20 students have yellow ruler. Number of students that have yellow ruler, they are what? They are 20. You list everything out. That's the simplest way to solve it. Alright. How many students have rulers of both? So there's something in the diagram that I should have done before even passing on this. Whenever you have two connecting circles, so the thing between these two circles, imagine suppose this one is A, set A, and this one is set B. So the point where two circles are joined, two oval shape are joined to make a Venn diagram is what we call the intersection point. You understand? So now I analyze A intersection B. So this is where they are connecting. So this place is what we call A and B, or both A and B. Both A and B, or you say A and B. So this way you can use both to represent it. You can use both, and you can use and to represent it. You understand? So that's what they mean. So they said that how many students have rulers of both colors? So this color, the first color is white, and the second color is yellow. So how many students have these two colors? They are the middle, because this is where they are connected. So the both students that have the two colors is here. So that the expression is number of W, that's white, intersection this. So it is on me. Okay. So students that have both color, we are only having two color here, white and yellow. So it is expressed as this white and yellow color. Number of students that have white and yellow color. Alright, so sorry, I'm looking for duster. I hope this is clear. Anyway. So now, do we have anything like nether unknown? No, we don't have it. So since we don't have nether unknown, so we are good to go. These are the things we have in the question. So how do you solve this problem? Even you can solve it without using Venn diagram. So the first method is, they didn't ask us to use Venn diagram, so you follow the instruction. But I'll use the second method to do Venn diagram. So how do you solve problem without using the Venn diagram? So what you do is that after listening out this, you now start with, let this one be the last thing you will touch. Start with the individual one that you listed. Start with the one here. So you're having number of white. This is how you express it. Plus number of yellow, whatever you have, those single one, minus number of W intersection Y. So anywhere two are connected, like this one is because two are connected. Anywhere two are connected, we always carry a negative symbol. But anywhere 1 or 3 are joined, we always carry positive. Any other thing, we carry positive in Venn diagram. But except where two two sets are joined, that's where they always carry negative. That is the rule. Anywhere two sets are joined, we always carry negative symbol. But any other thing as except this, we always carry positive symbols. So after doing it like this set plus this one, because this one I say anywhere two are joined carry negative, then everything you have here, no more thing, no more set there again, equals to the inverse set. So another condition is that every summation, whether summation of every set in a Venn diagram, all must equal to the universal set. The summation of all Venn diagram, like all sets in Venn diagram, must all equal to the universal set. So I'm trying to look for a sentence to dish out for you to understand what I'm talking about. So the combination of all the sets in Venn diagram, all must equal the universal set. Aside that, you have to know that where two sets are joined in Venn diagram must carry a negative sign. That's what I'm trying to say. So remember how we started, we listed out our parameters, then we patched out this concept. So what did they give us for this? They gave us 25 for this, plus they gave us what for this? 20 minus this one is unknown, this is where we are looking for, then equals to 30. So we have this one plus this is 45 minus the one we have that is unknown. Alright, so from here we collect like terms. CLT, that's minus this, equals to 30 minus 45. So we have this equals to, this one is minus what? Minus 15. Minus cancel minus. So these are the number of students that have both color. So you use your units to be your student because they are talking about students. So 15 students as both colors. So alternatively, the way you solve it in your secondary school. Alright, so you have to draft out your Venn diagram. We have this circle here. So this is your number of A. This number of, the first color we are talking about is the white. This is the white color, this is the yellow color. Okay, so what do we have for the yellow color? We have 25. This one is unknown. This is where both of them are joined, the two color. This place, the students that have two color are here, because they are joining here, both color are here. So it is unknown, it is X. And we are having 20 for yellow. So for you to know, do you know the reason why they used to put minus the unknown one that is here? The reason is because for you to know the exactly, when they said 25 did 25 as white color, 20 as yellow color. Look at what they said, 25 as white color, 20 as yellow color. And at the end of the day, we don't even know this one. Fine, we don't know this one, but we know this and this. If you add this one together, remember that I said the combination of all the sets must be equal to inverse sets. If you even add the one that they gave you on ground down, you will see that it is more than what they gave you as an inverse set. And for your answer for you to know if the answer is correct, you need to add the number of data sets you have inside the question. By the time you add everything together, it must be the same as the universal set. So if it is not the same, it means the computation is wrong. It means your answer is wrong. So that is how you test if the answer is correct. So now, in this place, if you add it together, you can see it's even more than the inverse set, which means that this one is just a temporary figure for you to get the actual value. Sure you get. So now, the reason is because inside this middle side, this middle where white and yellow, where those that has white and yellow is, this one, part of this one is here and part of this one is here, it's present here. So for us to get exactly this white, as when they say that, okay, find exactly those that has the white color. So that means the value we later got here, we have to subtract it from this one to give us exactly those who did the white. So that is the reason why we have to put minus x. Exactly those that have white. White is still inside this one. White and yellow is also inside this place. White and yellow is also inside here. So that's why we use put minus x. So also put minus x. If it is y you are using, you put minus y. If it is p you are using to represent here, you put minus p minus p. So our universal set holds for this side. They give us 30. So what do you do in this case, your secondary school approach? Just add everything. Remember I said that by the time you add everything inside this box, all the number that you have inside this box, all the element of those cells that you have inside this box, by the time you add everything together, it must give you this. If it's not giving you this, then something is wrong somewhere. So that's what brought about you adding all these things. Then you now have 25 minus x plus x plus 20 minus x. You add everything, add this one, add this one, add this one. You understand? Because this one is unknown, that's why I'm putting minus one minus x. As mean this one is known in the question. Imagine they gave me this one in the question. That means if you put, let's assume that they give us 10 in the question for both. That means before you write any value here, you have to subtract what they gave you for this from what they gave initially. Then you write the actual value here. The same thing you are applicable for this place. That's it. So it's not that they will give you the value here already. They'll give the value here already. You now still be writing minus x. No, you subtract the value they give you here already from whatever they give you originally for this side. Anyway, 25 minus x, this one is on x. Whatever you have here is what will determine what you are going to subtract from both sides. Equals to what? 13. So this one is gone. This one is 25 plus 20 minus x equals to 30. This 45 minus x equals to 30. X minus x equals to 30 minus 45 minus x equals to minus 15. This cancel this, x equals to 15, which implies the number of white and this. So this is it. So to check, so let's find exactly W. How do you represent it? We are finding exactly those that has white. Exactly those that have white. Let's find exactly this. Imagine they came up with that question. So exactly those that has white will be represented as number of W prime. So it will be carrying prime. No. Okay, exactly those that have white. Sorry, this is how you represent it. You know they are connected here. So we are having white and we're talking about white and yellow. So in a question, they have to like exactly those that have white. So since they are talking about white, they ask you the question exactly those that have white. This one will carry prime because they ask you a question like exactly those that have white. So to find exactly those that have white, then that will be your 25 minus what you have at the middle. They are interested in only the value of white, and you know that in this place there is white and yellow here. So for us to get exactly those that do white, we have to subtract this from this so that it will dust away this yellow. So and we got our x as 15. That's 25 minus 15. That's 10 students. So this one exactly those that has yellow. Exactly those that has yellow. So this one will carry prime because they said exactly those that have yellow. That this is the expression for it. 20 minus x. Then our x is 15. So this one will be 5 students. So now we have both color. Those that have both color, that's W intersection equals to 15. X equals to 15. So add up. So by the time you add up, you have this one plus this one plus number of this equals to, what do we have here? 10 plus 5 plus 15 equals to 30. You can see it is giving me the universal set. So you can see this one is correct now. So remember I told you that where two are connected, they used to carry minus. Do you know why this one is not carrying minus? Because the expression is different from what I am talking about. This one is exactly white, so it is having prime. So after getting the actual amount here, then the actual value here, like we got 10 here, we got 15 here, and we got 5 here. So if you now add up this and this and this, you see that it must give you what you have here. Then it means your answer is correct at the end of the day. So I believe you understand this video. I'll do one more example for you to understand the concept. Thank you. Thank you.